Good morning. I'm Jonathan Hawkins. I'm a program manager inside the runtime kernel, and today we're going to be talking about how we use transactions and other complex services in the .NET framework. Today we're going to show a brief demo of a bank app, which we've shown a couple of times in the past, of where we have a set of components which are going to be hosted inside a complex app. We have these components written inside VB6, VB7, and C#. We are then going to be doing a brief overview of complex services. Then we're going to show how we can host these new components for .NET inside complex services. We're going to show the programming model. We're going to show how we build and deploy these new components. We will go into some depth inside the new Microsoft.com services namespace, and then we're going to dive down into the code. While we dive into the code, Frank Redmond is going to come up on stage and give us a demo of QC. So if we take a look at this particular app, we see we have a SQL Server database on the far right. And this is where we store our state. In the middle, we have two components, where we have move money and we have account. These components are hosted inside a complex 1.0 application. And on the far left, we have the bank client. This bank client is written inside VB6. So the scenario is that Joe owes John $500. And what we're going to do is we're going to use the bank client, the components, and the SQL Server database to perform this transfer. So the user fills the details in on the bank client and clicks a button. The code behind the button creates an instance of move money. This move money component is sitting inside a complex app. The complex catalog has recorded for this particular component that this component needs transactions. Move money then creates an instance of account for Joe. Since account is also hosted inside a complex application, and it is also configured with transaction required, complex services flows the transaction from the first component to the second component. And this is just like MTS. The account component then makes a database connection through to the SQL Server, and we flow the transaction. In fact, the ADO Resource Manager knows about complex 1.0 object contexts and goes and retrieves the transaction and flows it through to the SQL Server database. The SQL Server database is then used by the component to update the bank balance for Joe. And in this case, we decrement the balance by $500. Flow then returns back to move money, where it creates a second instance of the account component for John. This component is also configured in the complex catalog, which is the configuration store, and it also has transaction required. Likewise, it opens up a database connection, and we flow the transaction. So this is a familiar sample which we have been shipping for quite a while. When flow returns back from move money to bank account, then complex services will automatically commit the transaction for us. So let's take a look at the demo machine. So we see on our screen, we have the first account number, and then we have the transfer to account number, We have the dollar amount of $500. We're performing a transaction type of transfer. The component that we're using is move money. And we see down the bottom that we have the 3 different language types. So this is a standard VB6 client, and we're going to hit all these languages. So when I hit the button, we'll go through that operation. We see down the bottom that the balance on account 2 is now $12,500. So we had a credit to that account. And the account balance for account number 1 is now $10,500. And all of these components are participating in the same transaction. I can do that same operation for VB7. And we see here that the balance on account 2 has gone up to $13,000, and the balance on account 1 is now at $10,000. I'll do the same operation in C#, and we'll see that we've had that same transfer of $500. So the thing to note is that ComPlus Services is providing the services for these components for transactions. If we go into the Component Services Explorer, we'll see that we have the move money component inside the different languages. We also have the get receipt component inside VB7. If I can bring up, zoom in, we'll see that we have got the VB7 bank, get receipt, and we'll see that we have 10 instances in the pool. So for the first time, we now have object pooling inside VB7, and we didn't have that inside VB6. So the point to note is that all of the languages inside .NET now have access to all the services inside ComPlus Services, be it transactions, pooling, QC, and any of the newer services which we have inside ComPlus 1.x. Let's go back to the slides. So what is ComPlus Services? We started off with MTS, where we introduced automatic transactions. Prior to this, developers had to use manual transactions. This means that they had to open up the database connection themselves, perform a begin transaction, perform a SQL, perform a set of updates to the database, and then commit that transaction themselves. This was great if you were dealing with a single table in a single database on a single machine. However, if you wanted to update state across a set of databases, you had to flow that transaction yourself. This became very cumbersome and sometimes very difficult to debug. So ComPlus Services brought the concept of automatic transactions to COM components. And this gave us the ability to mark the policy or the transaction requirements for that component inside a catalog. The developer didn't need to derive from a base class or even go and perform all those transaction operations by themselves. So MTS would automatically provide the transaction, and the resource managers for things like ODBC and ADO were updated to go and participate with with MTS transactions. MTS also introduced the concept of role-based security. This was the ability for the component, for the developer to put code into the component to check the identity of the caller against a list. And this eased programming. MTS also introduced some really cool admin tools which helped actually sort of operating these components. ComPlus Services builds on that foundation. We shipped it inside Windows 2000, and we are shipping newer features inside Whistler. So some of the features which we introduced inside Windows 2000 were things like object pooling. So object pooling gives us the ability to use components which are very expensive to create from a pool. So if I take the scenario, I will do an actual new on a component. Complex Services will take a look in the pool and see that we don't have any of those components. It will create one of those components and return it back to us. When we are done, Complex Services will put it back in the pool. And any other components which are running, when they do a new for that expensive component, they will get it out the pool. And Complex Services allows you to set the size of the pool. So you can even warm start your actual pool for these very expensive components. And this works today with VB7 as we've just seen it. Complex Services also gives us the ability to do queued components. And what this means is that we can record a set of calls, for example, on a purchase order, batch them up in a queue. The target component is then delivered those calls where we play back all the calls on the target component. This can all be wrapped in a queue. And this is really, really great if you're doing some type of commerce type of application where you're sending purchase orders and you want to batch those. Complex Services also brought to the table complex events. This gave us the ability as a developer that you didn't need to take care of firing all your events. Complex Services or complex events would actually do all of that delivery for you, and this was great. Complex Services also gave us features like auto-completion and compensating resource managers, which I'll talk about in the next slide. So MTS gave us this ability to mark attributes on our components. And we could do things, say, transaction required, or say, transaction requires new. MTS also gave us XA compliant resource managers. This gave applications which were hosted inside MTS the ability to interact with data stores which supported XA, such as Oracle. This gave the ability for those components to go out and touch all those other data stores. MTS also gave us COM-TI, the COM Transaction Integrator. This gave those same applications inside MTS the ability to go and interact with applications running inside environments like CICS and IMS. And this gave further reach for those applications. COM+ has improved the programming model by providing capabilities like autocomplete. This gave the ability that the programmer could actually mark the actual particular method with the programmer could mark the component method with a tag, and this gave the program module some flexibility so that the programmer didn't have to call setComplete. As long as the code inside the component didn't throw some type of exception or return some error code, COM+ would automatically call setComplete for you. If the component threw some type of exception, then COM+ would call setAbort. So Complex Services improved the programming model. COM+ also brought out the compensating resource manager. This gave us the ability as a developer to build newer resource managers, but without having to build all the code for the resource manager. The compensating resource manager provides most of the components for you, and you have to do the thin layer, and then you're done. Complex services also brought TIP to the table, the Transaction Internet Protocol. And this further extended the reach in the same way that XA and CompTI extended the reach. TIP extended the reach for applications which were hosted inside CompTIA to go and interact with those resources which could support TIP. CompTIA also brought BYOT, or bring your own transaction. This gave your components the choice of providing their own transaction to CompTIA, and CompTIA would put it into the CompTIA object context. So we've seen that we've been building these services inside MTS, and we've been making them better inside CompTIA services, and we'll make them even better when we ship Whistler and the future releases of the OS. So the point to note is that CompTIA services provides all the services for components, including components which are written inside, say, VB6, or even components which are written inside VB7, which are now called, say, .NET components. Well, .NET components, when you put them inside a CompTIA app, are really CompTIA components. So I can take my .NET component, I can add it to a CompTIA services application, and we can use all the CompTIA services, these being transactions, these being just-in-time activation, these being queued components, CompTIA events, activity synchronization. Any of those services can be used. And we're now going to go through some of those details. So .NET components get activated in a CompTIA object context. And the CompTIA object context is built from the CompTIA catalog. And once we've built that, we get this great integration with existing CompTIA apps. So I can have a VB6 component and a VB7 component, and I can flow the transaction or any of the other services between those two components. And if I had a third component done in C# or inside C++, I could flow that transaction all the way down. So we get this great integration. This is really great news for third-party languages. So you've probably seen at the conference that we have probably about 15 to 20 languages which can now support .NET. All of these languages get the same capabilities and the same APIs which things like VB7, things like VB6 and C++ could do in the past. So the programming model has been improved in .NET. Improved in the sense that I can now have these service custom attributes such as the transaction attribute, and I can mark them on my class. I can specify them as an actual developer on the class. When I compile that class, we compile those custom attributes into the DLL. They get stored inside the PE along with things like the IL, and we store them inside the metadata. This metadata is used to configure the CompTIA catalog. If you think to it in the past that VB6 used to give you the choice of choosing your transaction requirements from the IDE. When VB6 compiled that component, they would go and put a particular entry inside the TLB. In C++, we used to be able to go, and we can still do this, go into the IDL and put our transaction requirements inside the IDL. And when we put it through middle and we got out the TLB, then we would have those attributes inside the TLB. This is a similar concept which we're going to exploit in the future or use in the future to mark components for future services. These entries inside the metadata turn on the COM+ services, and I've said this before, is that these mark components are created automatically in the COM+ object context. For example, if we have inside the C# bank namespace, we have account, and we have a post method. This is the code sitting behind the account component, which we showed inside the demo. The first thing which we do is we make an actual reference to this new namespace, which is Microsoft.com services. This gives us access to all the APIs and all the service custom attributes for COM+ services. The next thing that we do is on the class, we mark it with a custom attribute. And in this case, we see we have transaction attribute, and we want transaction option dot required. So we have now marked the class with our service requirements, and if we follow the standard MTS or COM+ services programming model, the next thing is we begin to use resource managers to update state inside the resource. So today, you can use regular ADO through COM_interop. You can use MSMQ through COM_interop. You can use any of the third-party resource managers which have been built, which work with COM+ services, and things just continue to work. All of the services are available. You can use some of the newer APIs, such as ADO+, which you can find inside system.data. You can also use the newer APIs to get access to MSMQ, which you can find inside system.messaging. All of these APIs are aware of COM+ services, and they will automatically enlist in COM+ transactions. So if we see here in this C# code, inside the try block, I can do some operations against the resource. If we take a look at the programming model, we follow the standard sort of MTS or services programming model, where we can use things like setComplete if we are happy. So if we have got to a part of our code where things are good, we have managed to update all of the resources inside the database, we haven't had any exceptions thrown, we haven't had any error codes returned, we can then call contextutool.setComplete. If we are not happy and bad things have occurred, then we can call contextutool.setAbort. The thing to note is that this is slightly different from what we had inside VB6 and inside C++. We now have a common API across all the programming languages. So if I'm a VB programmer, I now call contextutool.setComplete. And if I'm a C# or a C++ or a COBOL or a Perl or any one of those languages, I call the same API. And all programming languages get access to all the APIs. So if we take a look at this, I get to the end of the try block. Life is good. I can call setComplete. If things are not so good and someone has thrown an exception, I can call setAbort. And when we go and look at the VB7 code, VB7 now supports try-catch, so I can perform a similar operation. So we've now done our code inside our class. We've now called setComplete. We now come along to build these .NET components. So a couple of talks have spoken about assemblies. The general concept for assembly is it's the collection of all the parts which are needed for your component. And for your assembly to be used by complex services, you need to provide a shared name. This is to enable complex services and .NET to provide the component correctly. So there's a command line tool, SN, that provides the shared name for the assembly. When we come to compile our code, if we have our 10 files for our source, we compile the code into the assembly as one of the options on the command line. To the compiler, we provide the shared name file. So the next step is we've done our code, we have now built it, we have to come to deploy it. So I can either take my component and put it inside an existing complex application, or I can create a brand new complex application using the complex component services admin, or I can use a set of scripts and use the complex admin APIs to go and create those complex applications. The next step is that I take my assembly and I add it to the global assembly store. So this is the second step to enable complex services and .NET to provide the component. The third step is that I add my assembly to the complex application. And here we provide a command line tool where we provide the name of the assembly and the name of the app. As we move towards RTM, we're going to improve this process. So let's take a look about in what capabilities we have inside Microsoft.com services. So we have all these custom attributes which are appropriate for development time, such as transactions, such as just-in-time activation, such as synchronization. And we'll be able to put future custom attributes here so that we can represent all the services which will be coming online inside complex services. We've spoken a bit about this class context util. It's a common set of operations which we expect most developers will choose to use. We still provide, and I'll be demonstrating that, all the APIs inside COM services. But this is a nice condensed common set of operations. So we have things like set complete, set abort. We have things like is caller and roll. We provide common operations to determine if we are in a transaction or to get the transaction ID. And we provide a way to go and get access to the real object context. And there's a series of other operations on context util. The second thing is we provide access to all the complex services interfaces to components for .NET. So now VB7 components can now get access to things like iObject control to provide things like object pooling. So all of the complex services interfaces are available to all the programming languages in .NET. We also provide a component which helps you add .NET components to a complex app. What it does is we scan through all the custom attributes on the .NET component for the services, and we go and configure the complex catalog correctly. This is the component which our command line tool, Reg Services, uses to add .NET components to a complex app. For security, .NET components which are hosted in a complex app can use complex role-based security. So I can use the same security model which I've been using inside MTS or inside Complex 1.0 with, say, VB6. I can use that same programming model with VB7 and C#. We also give you access to the security call context. From that, we can get the security identity, so you can get access to things like the SID and the name. We also give you access to the security callers. So all of the capabilities which we have inside COM+ services, such as the security callers, where I can go and get the identities of all the people in the call chain wherever we have a security boundary. And that would be if I had two components inside two COM+ apps, and I had configured them to have different identities, we would be able to go see that call chain. I would also be able to go and see the identity of the bank client. For the PDC bits that you have today, we have to go one step further. We have to use the COM emulate attribute. This gives us the ability to put our .NET component into COM+ services. The first thing that we do is we add a GUID to the class. This is so that COM+ services and .NET can find that component correctly. We then perform two steps. The first, we put the COM emulate attribute on the class. It points to an internal class. So if we think about it, we had a count. We've just made it a count internal. We now have this proxy class, which is the public class. And this is what COM+ services uses. As we move towards RTM, we will reduce the need to have COM emulate. Now we're going to dive down into the code. Let's go over to the demo machine. So if we see here, we have VB6 code for account. Here we have the VB6 code. So we see here, I just opened up the VB6.cls file, and we see that they marked their transaction mode inside the file, but it is not placed on the class. If we scan down, we'll see here that we're calling isCallerEnroll to check if a person making a transfer of greater than $500 and they are in the role of manager. If this is not true, we can raise a VB error. We then perform that connection to the database and we update the state. We then go and retrieve the balance from the database so we can present it back to the user. So this is standard VB6 code which we have been shipping for a while. At the end, we call setComplete. So the same programming model inside VB6. Let's take a look at it inside VB7. The first thing to note is that we make a statement to import from COM services. This gives us access to all the custom attributes and all the APIs. We see that we have the transaction attribute on the VB class for account. So this is right in the code. We see here that you can call contextutil.isCallerEnroll, and we can perform that same business operation to determine if the caller has the role of manager. So we have the same programming model from VB6. We have that same programming model inside VB7. And if you note the line below, we're actually throwing exceptions inside VB. We then perform the same operations to go and update the database as we did inside VB6. And again, we go and retrieve the balance from the database, and we can then return that back to the user. At the end, I've used a slight variation where I now have a try finally block inside VB. So here I can call contextutil.setComplete if the bSuccess is equal to true. And bSuccess will be equal to true if we get to the end of the code block, which is above. However, if I was trying to touch the database and something bad happened, let's assume the database server was not there. We would throw some type of exception. The finally block would still get called, and we would be able to call context_util.setAbort. In C#, we use the same programming model. So we include this reference to COM services. We mark the class with the custom attribute, transaction attribute, and we specify the policy of transaction option .required. So the same programming model inside VB7, C#, C++, COBOL, and any of the 15 or so languages, we can use that same programming model. In the code, I call the same API, which is context_util.isCallerEnroll. So the same API I call inside VB7, I call in C#. And here, I just put the code inside a helper method. We have a finally block where I can call context_util.setAbort. So this is really, really great. Or I can call setComplete if things have been successful and have been able to update the database. So we see we can have try catches or try finallys. I can throw exceptions inside VB7 and inside C#. We're going to switch over to Frank Redmond, who's going to show you a demo of queued components working.
Thanks, Jonathan. I'm going to show you a demo here. If I can get my demo machine. Okay, excellent. So I'm going to show you the exact steps that are necessary to actually take a VB7 component and use it with some COM+ services, specifically queued components in this example. And the scenario that I want to describe is a common kind of e-commerce scenario where we're going to use queued components. And the basic premise is I have some application called take orders, for example. And take orders could be a web-based application, most likely. And what it does is it collects a bunch of information regarding the order itself. Okay, who the user is, what products they'd like to buy, how many of each they'd like to purchase, credit card information, things of that nature. Then what we would do in reality is we would validate as much of that information as we could, and then we would send it on to another application called process orders. But we would call process orders as a queued component. And what that would allow us to do is, if process orders isn't running, for example, what will happen is that those orders will sit into a queue, and they'll queue up over time. Then what I could do is during a least loaded time or something like that, when the servers aren't as busy, or an off-peak time of my application, like late at night when nobody's using those servers, I'll run my process orders application. Right? So I can schedule that application to run during off-peak hours to actually process those orders. So I'm going to start by showing you the actual VB6 code. And so what I've got here is I've got my interfaces defined in this particular project, and these are just VB6 interfaces defined, one for the order itself, okay, which tells me the order ID and the customer ID. Then I have the various line items. It just tells me I can add a line item to the collection, I can get the total number of line items, and I can get individual items. Then each individual item has a description and a quantity. The process orders component simply has one method called process order, and it takes in an entire order. Okay, so that's pretty straightforward. So these are just interface definitions that are done in VB6. Then I have order implementation, where I have actual implementations of those interfaces. Okay, so here's an actual order, and as you can see, it implements the iOrder interface. I've got some private member variables where I'm going to cache that information. And in my implementation, that's all I essentially do is cache the information, set these properties, and cache that information for the object. What's interesting is you'll note that this particular VB6 object is persistable. Right, so what this allows me to do is when I make the call to process orders and I pass in an order object, this entire object will be persisted into the MSMQ message and be placed into the queue. To represent my kind of take orders application, which is available 24/7. I always want to take those orders, even though I might not process them till later. I've got a VB form. It's a pretty cruddy user interface. And this is all based on code, a sample, a QC sample that ships on today's platform SDK. And I've modified it slightly to fit this example. But this is, again, just the VB6 client. I fill in some customer information, the order ID, the various line items, how many I'd like to buy, and whether or not I'd like that operation to be queued when I actually click this button to process that order. And if you look at the code behind process order, you'll see here that I essentially create an order object. So here I create a new order object. I set the properties on it based on the text boxes. I add the various line items. Then I try to process the order. If it is going to be queued, I'll use the queue and new monikers when I actually go to create the order services process orders component. Once I've created that component, I will call process orders and pass in my configured order. Okay, so that's pretty straightforward VB code. Then I'll do the proper thing in terms of cleaning up. Okay, so this is all in VB6. The part that's interesting is in VB7. Okay, so here I've got VB7, and what I've done is I've just created a class library, a VB7 class library. I've created a new class called process orders. And what I would do is I would actually add a reference and I will go to classic com. Thinking. Still thinking. Still thinking. It's going to work, don't worry. Okay, you have to go find all those type libraries. Okay, so I'm going to go down here to the order interfaces that I've declared. Okay. Order interfaces, I would select that, and that'll create a reference. Then I would actually import those interfaces. Okay, that's all I'm doing here. So inside my order services namespace, I have the process orders component. Here's my constructor, which simply calls the base class. Here's my destructor. You can see here, just like in VB, I want to implement the iProcess orders interface that I've defined, and it's got the little underscore here, just as you would expect in a VB application, a VB6 definition of an interface. The thing that's different, one of the things you'll want to notice is the way you actually go about implementing the various methods on an interface that's been defined. What I do is I declare a regular subroutine, a regular sub, process orders. I declare it with the same exact signature as the method that I want to implement on the interface. And then I have to say implements that particular method on an interface. So this is slightly different than the interface name underscore method name that we're familiar with in VB6. Okay, so that's just a word that's wise. Then all I'm going to do is simply display a message box that's going to tell me that the order's been processed. It'll tell me what the order number is, and it'll tell me who the customer is. Whoops. And it'll tell me who the customer is. Okay, so that's pretty straightforward VB7 code there. So what you will do, and this is again, these are the exact same bits that you got handed out here at the PDC that I've installed. What you would do is you would go, I'm going into the command line compiler here, and I'll actually just take a script that I wrote for the VB7 compiler, and I'll explain what's happening here. I'm going to paste that in. Okay, so let's look at what I'm doing here. I'm going to call the VBC compiler. The output of this is going to be an order services DLL, that's the name of the file. It's actually going to generate an assembly. I'm saying that I want the output to be a library application versus a standalone executable. The file that I want to compile is called processorders.vb. I'm including a reference to the order interfaces DLL. and I'm going to import the Microsoft.Visual Basic namespace. Then, just like Jonathan said, I'm going to specify the shared name key file, which I've already created using the sn.exe command line tool that we provided. So you run sn, and it'll -k, and it'll generate a key pair for you. Okay, and it'll put it in a file. And I've just named that file orderservices.snk for shared name key file. And I specify that key file here as assembly.keyfile, and I just specify the name of it. Okay, so I'm going to run that compile script, and everything works great. The next thing you need to do is actually register those in the global assembly cache. So I use the assembly linker /install option. Whoops. Actually, let me shift to it. Output that to the bin directory. So now I will install order services.dll assembly linker. Okay, great, no problems there. Now the next thing I need to do, by installing that in the global assembly cache, I've now made that available to all of the COM+ users on the box. But now I actually need to go create a COM+ 1.0 application. So I've got the Component Services Explorer up here. Create a new application, just like you would today. I'll call it Process Orders. This is going to be a server application. Okay, now here's Process Orders. But now I'm going to go back to the command line to actually, and I'm going to run a different tool called reg services that's going to actually take the assembly information and add that metadata information directly into the process orders application that I've just created inside of COM+ 1.0. So I'll run reg services, and I'll specify the name of the assembly, which is order services.dll, and the application that I want to add it to is process orders. And we can see that it has installed the assembly successfully. So now if I go into process orders, you see I have that particular component is now installed and available for me to configure, just like I would configure any other COM+ component. And in this example, since I'm using queued components, I'll pull up the computer manager, and you can see here, I'll hit refresh, that there are no public queues. But when I go in here and say that I want to make this particular application queued, and in fact, I'll go into the iProcess orders interface is the one that I also want queued. Now if I go back to the computer manager and hit refresh, you'll see I have a process orders queue. And currently the queue is obviously empty. Okay, great. Now I'll actually run the client application that's going to take these orders. Here's my CRUD interface. And customer 100 is going to have an order number 200. They're going to order 5 units of item 1. And I want that operation to be queued. Okay, so I'll call process orders. Nothing seems to have happened. But if I look in the queue, and you refresh the contents, you'll see I have one message. Okay, so now that order is in the queue. And I'll do some more orders. Let's say that customer is going to buy, they're going to buy order 300, they want to buy 7 more units. Okay, and I hit process. If I go back to computer manager and hit refresh, you'll see there's another order in there. So this is the kind of thing I would do to get more throughput through my system, right? I'm just taking these orders as fast as I can. I'm not actually processing them in real time, okay? Here's your receipt number. If you have a problem with this information, I've got your email address. Thanks for shopping here. We've got your order. But I'm not actually going to process that order until some later point in time. Or I'm going to use dedicated hardware and dedicated back-end systems to actually process those orders. Okay, so I've got 2 orders in there. Now what I would do is at a later point in time, I would come to my process orders application, and I would most likely write a script in VB script or JScript or something like that to automate what I'm about to show you right now. I would go into properties, I would go into queuing, and then I would turn on the listener. And the listener is just this thread that's watching this queue asynchronously for orders that are coming in there. And what's going to happen is the listener will pull those messages off of that queue and forward them to a special stub that's essentially a player that knows how to unravel the contents of that MSMQ message and play it back to my process orders application. Okay, so I turn on the listener. Then I would actually start the application. And as you can see, when I start that application, it goes through, pulls those messages off, and in fact does process them. You can see I processed order 200 for customer number 100, and I've actually processed order 300 for customer 100 as well. And if I look in the computer manager, both of those messages are gone. So now that that application is running, any additional messages that come in, any additional orders that come in, I'll do order number 400, it'll go ahead and process those in what appears to be real enough time. So as you can see, it's very straightforward the steps you need to take to actually use these COM+ services from the new .NET framework and the new .NET platform. Okay? That's exactly what you have to do. I'm going to turn it back over to Jonathan, and he'll wrap up for us.
Can we get the slides back? So we've seen that we have these really, really great services inside COM+ services, and other parts of the .NET framework actually use these services. For example, ADO Plus provides a SQL Server provider which is completely written inside managed code, and it uses the SQL Server TDS protocol natively. This is the protocol that SQL Server can understand. The SQL Server provider uses COM+ services object pooling to perform connection pooling. And the way it does this is it puts a helper object in the pool, and this helper object holds on to the connection to the database. The SQL Server provider also does automatic transaction. It will also go and retrieve the transaction from the COM+ services object context for us automatically. Other parts of the platform, such as ASP+, also use COM+ services to get their services. For example, pages and web forms in ASP+ can be marked for transactions. The page or the form starts in a COM+ object context, and this is just like ASP. ASP+ web services methods can also be marked for transactions, and they also get started in a COM+ object context. So the thing to take away is that COM+ services provides all these services inside the platform. So there have been some other sessions this week which talk about services and COM, and you can go and take a look at the slides. We have also put in a document inside the SDK that will go into more detail of how you can use COM+ services from code which is managed. I encourage you to go and use the bits which we've given you and to provide feedback, and go and use the service attributes and go use the APIs inside COM services, and also use our tools. So we're going to turn to questions. Can we turn on the mics?
Hi. Hello. Hi, I've got a question about the client app used for the bank scenario. Was the app totally written in .NET, or was it a COM app?
Okay, it's a COM app. It's written inside VB6, and we did that to show that I could have VB6 code calling components inside .NET. That bank app could be written inside VB7, and we could perform the same operation.
But will it be a .NET app, or will it be a COM app with interop?
From your code, which is managed, you would just do new. Underneath the covers, because we're going into a COM+ application, we would use COM interop to get there.
Will that change in the future, or?
If you come and chat with us afterwards, we can probably talk about it.
Okay,
Question?
thank you.
Yeah, could you explain the account internal class that you, sorry, the account internal interface that you had in your example, in your bank app example?
Could you just repeat?
The account internal class, there was, as part of the custom attribute specification, there was something about account internal, which I did not understand.
Okay, so for the bits you have today, is you have account internal, which is your standard business object. Okay, and you have all of the standard interfaces, and you have all of those standard methods which you want to support on that component. You have this outer class, or the proxy class, which points to the internal class, and this is the class which COM+ services will activate. In .NET, we can use the COM_emulate attribute to find the actual real class. Okay? In future betas which are coming up, that will be going away.
Okay. Could I have done the same thing by just using the type library exporter to create a type library and then add the COM component to the, add it to the COM+ catalog?
Okay, so we provide the tool which goes through all the processes. You can run TLBX on the managed code, take that type library, and drop it into your COM+ app. Yes, you can do that.
Okay. Thank you.
Suppose I want to pre-JIT my application and run it in COM+ services. Can that be done? And does it make any difference if I pre-JIT it before I register it with COM+ services or after it?
We haven't tested that particular option, but come and see us afterwards, and we can probably chat about it.
Okay.
I've got a simple question. Have I understood it right that the .NET framework exclusively uses COM+ services as component services, or does this framework introduce its own set of component services?
So .NET uses all the COM+ services, and that will be the place where any future services come from.
Thank you.
I noticed in the invocation you placed attributes on your .NET object, like the transactional requirements of the object, and the infrastructure was sensitive to these attributes, and therefore when the object was created, it successfully genned up a new transaction as part of the object's context. However, in the .NET framework, the attribute facility is an extensibility point. Users can define their own attributes. Is there any way to get the system to respond to these attributes and perform other kinds of interception when objects are created besides the ones that are set up explicitly for COM+?
So today, no. But in future, I'm sure we'll expose some type of mechanism. And if you come and chat to us afterwards, we can probably talk about that.
Okay, so you wouldn't want to speculate for us what that might look like?
Come chat with me afterwards.
Okay.
I didn't quite understand what is in the registry and what is metadata. Is the command line utilities you showed us still place all the things we know and love in the registry for the COM object?
Yes, it does. So when we run that command line tool, we actually make the .NET component look like a COM+ component, and we put it inside the registry.
So that's when the COM service contains .NET components.
Correct.
How about the other way around? Or does that exist?
Are you saying, can I use COM components from .NET?
Yes.
Yes, you can. So there are a couple of samples to do with COM interop where I can take components which are COM, which are, say, written in VB6, and bring them into .NET, and you can use them.
And then does garbage collection pertain?
So garbage collection will only pertain to .NET code which is running. But any of the references which we have to COM components, if they are not used inside your code, then we'll free up that particular reference, and then GC will take care of it, and GC will then free up the COM components.
Thank you.
My understanding has been that when you use COM interop, that imposes some amount of overhead over what you would have had to achieve if you just stayed in the managed environment. And I'm wondering if you can characterize, in a high transaction processing environment, is this going to add significantly, if you want to be able to use transactions, to have to go through the COM interop to the traditional COM services? Is there any way to characterize, how much extra overhead that's going to impose?
If we take a look at it today, if I'm going against a database and I'm performing transactions across the network, there's a huge cost just going across the network. There's a huge cost in just, say, coordinating a set of transactions against a set of databases. That cost completely outweighs the cost of performing, say, the 20 instructions to go from, say, native code, from say, VB6 code, from, say, VB7 code down to COM services. So the actual cost is really low when you compare it to the cost of using the database, going across the network, and doing the transactions.
And I want to add something to that. Over time, we will actually optimize the services code for the managed environment, right? So you actually get better performance over time from using the managed services as opposed to the unmanaged services.
Okay. Another quick question. When you went through those screens and you were choosing, you had gotten to the point where you were importing into your VB application in the VB7 environment. You brought up we waited a long time, as we do now, for the registry to be read and for all those type libraries to be discovered. I noticed another tab there that said assemblies.
Sure.
How does it find out about those assemblies, and is that likely to take as long these days as well? Or
So currently today, to find type libraries, we have to scan through, say, HK class's root and actually scan for all the type libraries. For assemblies, we have the global assembly store, and therefore we can go and actually find those files there.
And as you notice, when I pulled it up, that was the very first tab, and all the assemblies were already in there. Right, so it was actually when I had to click to the classic COM tab that it had to go scan through HK classes root/type lib. It had to go scan that for the type library and then peruse that. Right, but when I first pulled that add reference box up, the assemblies were already in there.
Okay. One quickie. The command line work that you were doing
Sure.
to come out, is all that stuff going to be integrated into the IDE eventually, or are you going to?
Absolutely. By the time it ships, it'll be much less painful.
All right.
But I just wanted to show you exactly what you would have to do with the bits that you have in your hands. These are the exact same bits that I installed on this box last night.
Yeah, I figured that. Okay.
Okay. I think we are going to run out of time, so if you want to come up to the front, we can take questions.